This is lesson 30, day 2. What we're going to do is we're going to finish up on this vector stuff, and then we're going to move on to some proofs. And this one's slightly different than the ones we've been doing, because the ones that we have been doing so far with our vectors was just find the resultant or find the equilibrium, which means add them together. In this problem, as you can see, it says what vector force must be added to 20 at 30 degrees newtons to obtain a resultant or result of 25 at 0 degrees. So now it's actually setting up kind of like an equation. Something plus the 2030 is going to equal 25,0. That's what we have to set up. So let's do that. I'm going to change the order around just a little bit. I'm going to do 2030 plus some vector, I'm just going to put a box there, some vector will equal 25 at 0 degrees, yes? That's what we're going to do. I'm just going to solve for that empty box, which is going to be a vector in polar form. So this really doesn't make much difference from what we have been doing, but instead of adding the vectors, we're going to subtract. Do you guys see that I'm going to take the vector that it's equal to and have to subtract out the vector from over here? We could do that right now, or you can do it after, but just like when we added them, we converted everything to I hat and j hat, or rectangular form. In this case, we're going to do the exact same thing, but instead of adding our i's and our j's, we're going to subtract, and that's it. So really there's no different. And this one doesn't turn out to be too bad because we have a 30-degree angle, which we should all know for the most part, and 0 degrees, which makes it a lot easier. It's one of our quadrantal angles. So let's just skip to that idea that we're trying to make things go quicker. We start recognizing a pattern. 30 degrees. Do I really need to draw out 30 degrees? Where is 30 degrees? It's in quadrant 1, and it has a reference angle of all angles in the first quadrant are positive, and they are their own reference angle. The reference angle to 30 is 30. The only way to get to 30 is 230. Okay? We're going 230. So that means x is equal to 20. What? Cosine 30? And y is equal to 20 sine 30? And this is why it's kind of nice, because you know the sine of 30. What's the sine of 30? It's a half. So technically, the y value turns out to be real nice, and that's 10. Cosine, though, cosine of 30 is square root of 2, or square root of 3 over 2. And what's the square root of 3 over 2 times 20? Take your calculator out. We'll go to decimals for this. 2 decimals. 17.32. Is everybody able to get that? So what does that become as a point, or as rectangular form? 17.32 I hat plus 10 j hat. Right? Yep. That vector is going to be added to that one we don't know, right? And it will equal 25 at 0 degrees. So let's figure out that information. Well, that's x equals 25. What? Not sine. Cosine 0. And y equals 25 at sine 0. Hey, cosine of 0 is? It's 1. Look at your quadrantal. That's taking one step over to the right. You're at 1, 0. Cosine is your x, right? So it equals 1 times 25, which is 25, and sine of 0 is 0, so 0 times anything. Hey, that's actually pretty easy. So what point is this? 25 I hat plus 0 j hat. Can you solve for I and j? What do I need to do? What do I need to do with these values here? Subtract them over to this side. And it'll leave me with the box, which is the vector, in rectangular form there. So I'm going to subtract 17.32 and minus 10 j hat, right? Gone, gone. And so minus 17.32 I hat minus 10 j hat. Yes? And so our box is going to equal 7.68 j hat minus that's yep. Minus 10 j hat. I should have wrote that a little bit smaller. That's your rectangular form. If I just said leave it in rectangular form, you are done. But we probably should put it in polar form because our answers were in, or our given stuff, information was in polar form. So you may want to draw this one out. Just make a very crude drawing, going over 10, or 7, but going down 10. So there's theta, there's r, going down 10, right? So that's a negative 10, and 7.68 is going over. You find theta, you find r, but theta is not the right angle, it's the reference angle, right? Remember, we want the positive angle, so we have to go all the way around that circle to get there. But how do we find r? Yeah, it's just the side squared. 7.68 squared plus a negative 10 squared. So if we take our calculators and we square 7 something, we know it's probably going to be in the 50s. 10 squared or negative 10 squared is like 100. So we end up with 150 something. 158 point.
Wait,
Is it 158?
yeah.
Point 98. And we're going to square root both sides. So r is equal to 12 squared is 144. 13 squared is 169. So therefore it's 12.6. Exactly? Not exactly, but close. 0. Okay. So 12.6 is good. That's my radius. That's how far I'm going to walk out. Now we need to find theta. And I'm going to squeeze that in here. Theta is equal to the inverse tangent, yes, of the ratio. And what is the ratio? What's opposite? Negative 10 over 7.68. Now, guys, like I've been saying all along, you can ignore the negative on the 10. Because you're finding the reference, and all reference angles are positive. If you leave the negative on there, you actually have one of your thetas that of the 4 answers in polar form. But we will ignore that. We'll use our brain to figure it out. Theta is equal to 50. What? 52? 52.5? Oh, we better check this. Okay, so we made a small adjustment to 52.48 for theta. Now, remember guys, this theta is here. So I don't want to be here. I want to go the angle that goes all the way around to there. So So what can I do? Subtract it from 360. So if I take 360, I'm going to have to move up here. 52.48. I get theta to be 0.52. And so the answer for inside that box shall be what? What was my radius? 307.52. Thanks, guys. Is the vector that would be added to 20 at 30 degrees to get me to 25 at 0 degrees. Pull it one. So it's a different way of thinking on there, but it uses the exact same rules and things that were applied just by adding them. The second half of the lesson deals with overlapping triangles. Now, we have done proofs with triangles before. Side, 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 angle, side, angle, angle, side, hypotenuse, leg, and what's the other one? There's one less. Angle, side, angle.
Angle, angle, angle.
No, angle, angle, angle proves similarity, not congruency. And remember, there's no donkey postulate. Okay? Now, the problems we did before, and I'll erase it, were these ones. We had problems that were set up like this. They weren't overlapping, but yet we could say, hey, they have some vertical angles. The lines may have been parallel, so you can do alternate interiors, stuff like that. That was before. Now we're given a problem like A, B, C, D, where our triangles are overlapping. Now remember, because we're doing proofs, that we have to do a 2-column proof. So you have statement and a reason. Anytime you do something, you have to back it up with a proper mathematical reason why you're doing it. Givens, always number one statement. And the reason, yes, is our given. So AB is congruent to DC. And BD is congruent to CA. Reason, given. Now, the second thing, guys, I always told you guys is go back into that diagram you had and start putting the tick marks in, right? But here's the thing. I'm not going to do that on that picture because that one has things that are overlapping. So what I'm going to do is I'm going to kind of cheat on this one a little bit and say, hey, what was the answer again? The answer was the two triangles are congruent. So what I'm going to do is I'm going to find out what they want to be congruent, and I'm going to separate them. I am going to separate them from that particular diagram. And so the first one was ABD. And ABD is ABD. So I am going to take this triangle of ABD and pull it out of there. I'm also then going to go to the other one of DCA. 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 And I'm going to pull that one out. So what this does is it allows me now to put my tick marks without having that crossing in between. It's going to make it easier for me to see sides that are congruent, angles congruent, and so forth. So now I can put my tick marks on. AB is congruent to DC. So AB is here, DC is there. And BD, which is kind of like the hypotenuse, the largest side, right? Is congruent to AC, which is also its largest side. Okay, that was given. What else can I do? I can't do side, side, side yet. That is the answer to prove that they are congruent. But I have to get there first. I only know two sides. And no, two sides does not imply all three. That only works for angles. So what is step number 2? What is step number 2, guys? Look back in your original diagram. Don't they share something? AD, AD. So what can I say about that? Not angle, but side AD is congruent to side angle or side AD because reflexive. It's the reflexive property. So now I can go to my triangles, say you and you are the same. Now we can go back and say the triangles are congruent because side, side, side. So triangle ABD is congruent to triangle DCA because of the reason of side, side, side. Done. So now we have another one. In this one, it's given this diagram and saying that line segment PQ is congruent to line segment RQ. And line segment QY is congruent to line segment QX. Prove that triangle PQY is congruent to triangle RQX. And so, again, we have the statements and a reason. And our first one is always our given. PQ is congruent to RQ. And QY, wow, missed that Q completely. QY, line segment QY is congruent to QX. And that's not a 2, it's a 1. And the reason is given. Moving on to number 2. But before I get to 2, I'm going to break it apart so that I can put my tick marks on there. Notice triangle PQY is PQY. So we're talking about this triangle here is congruent to RQX, which is this triangle. So PQY, that wasn't a good one. And this one's RQX, right? So make sure to separate them, make it a little bit easier for you. Now PQ and RQ. PQ and RQ are the outside ones. I'm going to change colors so we can see this. PQ, RQ, and QY. So the inside ones here are the same. So do we have enough information to say that PY and X are the same? I don't know about that. So I don't know if we're going to use side, side, side. What are they, do they, you know, the thing about proofs is we always try to go back to, can I say they share anything? Can I say vertical angle somewhere? I think most of us should understand that these two angles here are vertical. But are we talking about these two small triangles? No. We're talking about the larger ones. What is it? Yeah, Q is the same. They share Q. Q. So that means angle Q is congruent to angle Q. Why? Reflexive again. Not reflective. Reflexive So angle and angle are the same. Ooh, can we finish it now? Triangle PQY is congruent to triangle RQX, and the reason is why? Side, angle, side.